Welcome back to the channel by dear students. Today again we are going to look at another algorithm for sorting elements. Okay, let's proceed. Today we are going to look at what we call the selection sort. This is a both in place sorting algorithm and comparison based sorting algorithm. That is, here we are placing just like the insertion sort, and we are comparing just like the bubble sort. Sorry. It sorts an array by repeatedly selecting the smallest or the largest in case of descending order element from the unsorted portion and swapping it with the first unsorted element. That is, here we are not considering the first element to be in the sorted list. No, here we select the smallest element of the list and we swap it with the first unsorted element in such a way that after the first pass, we have our first element to be in its right position. How does it work? Examine each element in the array or list to find the smallest or the biggest depending on the order in which you are ordering your elements. Swap the smallest element with the first element in the array or list. Repeat step 1 and 2 each time, ignoring the element at the start of the last sort. Meaning that what? Pass 1, I will swap with the first element. Pass 2, I will swap with the second element. Pass 3 with the third element, and so on. Stop only when one element has to be sorted. Otherwise, we stop when we have just one element in the unsorted list. Technique. Sort the list that you have in ascending order using selection sort. Initially, that is the list we have, and you see that all of them are red, meaning that what? Here there is no element we consider to be sorted. How do we work with the selection sort? First of all, we identify what is the smallest element in the unsorted list, and we see that the smallest element here is what? Is 9. So I will swap 9 and the first element, which is 39. So I swap 9 and 39. This is what we have after the first pass. As you can see, this 2 has been swapped and 9 is now blue, meaning that what? It is in the sorted list and it's in the right position. I underline this for you guys to know which element were swapped, as you can see. Now, from the unsorted list, what is the smallest element from this list? Perfect. 18. So I'm going to swap 18 with 39, as you can see, because I swapped this is the second pass. So I will swap this and this. So I will swap 39, 18. So after pass 2, this is what I have. As you can see, I have swapped them. This is different from the insertion sort because remember, in the insertion sort, I pick one element and I introduce or insert it in its right position. Whereas here, I select the minimum element and I put it directly next to the last element of the sorted list. So now, what is the smallest element again from this? Perfect. 27. So with what am I going to swap 27? Correct. If you said 81, then you are correct. So I will swap 81 and 27 to get this. As you can see, the swapping has been done. Dear students, in MCQ, you will be asked some questions that for 27 or for 18 to be in high position, it was swapped with which element you need to know. So for this different technique, guys, there are a lot of questions where you can be asked. So it is very important for you to understand all these different methods that you are having. That is why I am making it to be byte by byte for you guys to understand very well. Let's proceed. What is the smallest element here? And we see that it is 39. So I'm going to swap 39 and 45 to get this. 39 and 45 have been swapped. What is the smallest element in the unsorted list? 45. So 45 will be swapped with 19. As you can see, this is what we get. What is the smallest element in the unsorted list? 72. So 72 will be swapped with 81. So this is what I get. So just as the insertion sort, as we gradually move, the unsorted list reduces while the sorted list increases. But the difference is that in insertion sort, the sorted list increases from 1 right up to the maximum, while unsorted reduces from what? The maximum minus 1 right down to 0. But here, the sorted list increases from 0 to the maximum. We proceed. The smallest element in the unsorted list, as you can see, it is 81. So I will swap 81, 81, and 81 is already in its right position because there is no element is going to be swapped with because it's already the element next to the sorted element. So no swapping. So this is what I have. And now I am going to end here because I have only one element in the unsorted list. That's what was said. We stop only when one element has to be sorted like this. So we stop when we have one element in the unsorted list. So guys, for each of these algorithm, you need to know how they work because the description can be given to you in MCQ. You need to know the technique because you can be given a list and you are being precise with the type of algorithm to use to perform the sorting. And another thing is that you need to know the conditions when these different algorithm stop. You need to know also their complexity and you need to know how to obtain their values after a particular pass. The algorithm of the selection sort, this is what we have. As you can see, enter the element of the array list. I have my variables. Now, as you can see, this is the block to get the minimum element. Do not be worried about it. When we shall be working on the data type and data structure, you are going to have the algorithm well explained on how to get the minimum and the maximum element of an array. But now, let me just explain for you guys to understand very well. This loop that is inside the box iterates from I plus 1 so that the previous minimum element obtained should not be considered. As you can see, when you want to know the minimum element, we don't consider this element that already blue. That is why j starts from I plus 1. Okay, and this is the block. So for each value of j, I will compare it with all the different, for each value of j that I have, I will compare it with the minimum value, and at the end minimum we take, I'm going to get the minimum value. As you can see, from there now I'm going to perform the swap with the actual value from the unsorted list, as you can see. So this is the swap. This is where the swapping is done, swapping the minimum item obtained and the first unsorted element. So this is the algorithm for the selection sort. Now, can somebody deduce what the complexity of this algorithm is? Come on, dear students. We can see that we have two for loop. But which kind of for loops is this? It is a dependent for loop because this inner loop depends on I. And we said that for dependent for loop, the complexity is simply big O to the n square. This is what we have. Because normally it's supposed to be big O of what? N square plus n. And when we apply the notation, we see that the complexity of the selection sort is big O of the n squared. Okay, I want to reveal you the algorithm we are going to treat in the next lesson, and that algorithm is simply the quicksort. Okay, dear students, we reach to the end of this selection sort. I hope you understood the concept very well. Do not forget to like, to subscribe, and to share. And in case of any worry, you drop a comment for me to know that you actually follow me and that you follow the lessons very well. Thank you for your participation. Thank you for your time. See you in the next lesson.